In this brief lesson, we're going to take a look at the Hadoop Distributed File System, or HDFS, access controls. We're going to browse through the history of access control in HDFS. We're going to take a look at the HDFS permissioning system, which is Linux-based. We're also going to take a brief look at Kerberos, the ability to add strong authentication into Hadoop. We're also going to look at how to sandbox new users by using a trash directory, as well as setting up HDFS user quotas. First of all, let's take a look at the timelines of Hadoop. In 2006, when Hadoop was released, it started out as a web crawler or indexer. It really didn't need any permissioning in the beginning, which gives you some insight into what we have now. Hadoop really didn't need any access control in the beginning, and it's hard for it to escape its history. In about 2008, we added HDFS read, write, and execute permissions, and we'll talk about those in a second. This basically allows us to protect our system so that honest people don't do stupid things, like accidentally delete each other's files. In about 2010, when Hadoop started making inroads into the enterprise, the developers of Hadoop added the ability for Kerberos deep auth, and we'll talk about that in a second. The two halves of access control for any secure system are authentication, which basically says, are you who you say you are? This is akin to putting in a password on a website. And authorization, which says, should you get access to what you're asking to get access to? You may be authenticated, but you may not be authorized. For example, you may be logged into a website, but you may not be the administrator and able to add and remove content. Or you may be authorized, you could be an administrator, but not authenticated, logged into a system. When you're using Hadoop, you have to realize that HDFS does provide authorization. It does check to see if I have access to the things I'm requesting access to. However, it does not do authentication. The way it does this is it checks the name of the user who's running the command on your local workstation. It should be noted that you have complete control over your user workstation. For example, I log into my local desktop as rmorrow. When I submit commands into the cluster, which is a separate set of machines that I don't have control over, Hadoop simply checks to see if the rmorrow user has the ability to write into HDFS. If, for example, I don't have the ability to write into HDFS, but decutting does, all I have to do is create a decutting user on my machine, and then run those same commands as decutting. I would then be able to go in and delete and add files that decutting would add. Hadoop never checks out of the box to see if I have passwords to log in as decutting. It simply checks to see if I'm running the commands as decutting, and if so, I have the ability to do those things in HDFS. We can enable strong authentication, however, with Kerberos, and we'll talk about that in a second. First, let's talk about base HDFS permissions. HDFS uses Linux-like read, write, and execute for user, group, and others. What this means is that each of the 3 bits that you see here, the RWX, each set of these applies for the user who's running those commands, the group that that user belongs in, and others who are neither that user or that group. Let's take a look at a couple examples. Some common permissions that we have are like 664, which says that the read and the write bits are set for user and group, and only the read bit is set for others. The way that we get at 664 is we take the binary equivalent of these numbers, 4, 2, and 1, and sum them up, so we end up with 6, 6, and 4. Another common permission that we see for directories especially is RWX, RWX, RW. What this means is that the specific user or the group that belongs to that file can read, write, and execute that file, but others can only read and write. They wouldn't be able to execute. This is a common permission that we see on directories. 600 or read, write with the rest of the bits set to nothing and read and write only set for user mean that only that user can read and write to that file. This is a common quote-unquote secure permission that I may use to enable only this user the ability to read or write to that file. In HDFS, the X permission really only means directory browse. We obviously can't execute files in HDFS. The X really has no meaning for files in HDFS. The W in HDFS means that either that user can write into a directory, or in the case of files, it means that that user has the ability to delete that file. For example, these RWR permissions for 664 means that the user or the group can delete that file and anybody can overwrite that file. As we said before, Hadoop can be enabled to use strong authentication using a system called Kerberos. Kerberos is basically a ticketing system. When I go to request access to some resources in the system, I'm redirected to a Kerberos ticketing server or a ticket granting service. That ticket granting service is something that's been around forever. Kerberos is a very battle-tested system, and it's used extensively in many projects, including LDAP underneath Windows. It provides short-term expiring tickets through that ticket granting service. Those tickets can then be validated by endpoints like the name node, job tracker, data node, and task tracker daemons. Although it does make systems very secure, it does add complexity and management overhead. This can be easily managed via Cloudera Manager. You should note that most clusters do not need this. An easier and better security mechanism is simply to drop your entire cluster in a protected or isolated network. This gives you not only additional security, but keeps your Hadoop cluster, which can be very spiky as far as bandwidth is concerned, it keeps that spikiness isolated to your cluster. You also guarantee that your cluster doesn't get any random effects from outside systems running in that network. We can then control access to that network via either access control lists or bastion hosts, little jump station servers that we first have to log into. These servers are the only servers that can then SSH or log into other machines in the cluster. One of the things you'll definitely want to do in your cluster for access control is to sandbox your new users. Users who are not used to a distributed file system can accidentally and unintentionally fill up an entire HDFS directory. To prevent this, you can use HDFS quotas. Using quotas means we can lock down a hard limit of the usable space per user. We could, for example, maybe give our newbie users an upward limit of 5 or 10 gigs of usable HDFS space, and then our more seasoned veteran users, we could give them maybe 100 gigs of usable space. We can also lock down a hard number of files and directories per user. This is especially important when you consider how much data you can fill up in the name node. If you remember, each one of those files and directories requires about 150 to 200 bytes of memory space in the name node. Locking down on a per user basis the number of files and directories that a single user can use keeps that single user from filling up the name node's memory. This is very easy to set up on the command line using the dfs admin set quota or set space quota commands. We can also use the fscount-q on a directory for reporting to see how much disk space and file objects a single user is using. This link on the bottom provides more information about HDFS quota administration.